So, that's enough theory for today. Let's go back, well for now anyway, let's go back to our terminal. Now where are we? We're in our project file still, so if we type git status, on branch master, nothing to commit. If we type git log, we've got all of our history. So far there's been 3 commits. And there's only one file, we've just changed the readme.txt. Obviously in real projects we're going to have more files than that. So, let's say we want to push our changes to our flash stick now. We just have this USB flash drive that we use as backup. Now, I'm going to do a little bit of pretending here. So, I have to... Bear with me. I should have done this before the video started. So, for this video, we've got this drive that's mounted in slash... Remember, this is Linux, so we have this drive mounted as flash stick in slash media. If you were on Windows, it'd be a different path. But that's all that changes. So this is our flash stick, and we're going to make it so we can push changes to that. So let's cd into our flash stick and make a directory called project backup. Now, inside here, we don't have anything. Now, one way that we could work is we just copy our working directory from our home directory over to here. But there's a better way of doing it. And the way we do it is to create another Git repository in this folder here on our flash stick. But we pass it a special flag called --bear. So, git init, just like last time, /bear. Created and initialized a Git repository in that, and if we type ls, we've got all this stuff here that we didn't see before. This is because we created a bear repository. Normally when we type git init, all these directories and files get stored in a .git folder that we never see. But because this is a bear one, it's going to be a little bit different. So, let's go back into our home directory and then into our project directory. Before we can... So at the moment all these commits are local. We haven't got a backup anywhere. They're not being pushed to a server or anything like that. They're only stored locally, which is fine because we get all the history and all the benefits of Git, except if our computer crashes, we've lost everything. Not a good way to work. So we're going to create a remote now. Incidentally, if we come back over to here, get rid of all this. I need a whiteboard eraser. Okay, so in Git we can have multiple servers, and in this case this is going to be our flash stick. And we can push changes to here, and we can push changes to here, which we'll set up as well, and pull changes from here, fetch changes. In Git, these are all called remotes. Okay? And we can add as many of these as we want, and we can push to them individually, or we can push to all of them at once. But before we can do that, we have to tell Git that we have a remote that we want to push to. So we do that really easily. Come on. We do this with the command git remote. So git remote, we're adding a remote. Now what goes next is the name of the remote and then the path that Git uses to get to it. So I'm going to call this flash stick. That's the name of this remote. And then the path to it will be /media/flashstick /project backup. So that's all we did. So git remote add. We're adding a remote. This is what we're calling the remote, and this is the path to the remote. Okay? Now, how do we push our changes to the remote now? Well, if you've been playing along at home, you'd notice that I've been saying push an awful lot. And that's exactly how we do it. We type git push, and then where we're going to push to. So the name of the remote. Now the first time we do this remote here that we just created on the flash stick is completely empty. So before we can push, we need to create a branch on this. So we're going to have the branch master. We'll talk about branches a little later, but for now we have to create this branch. So that happened really fast because it's pushing to a flash stick connected to our computer, and it wrote really fast. So what did it do? It counted the objects that needed to be pushed, it compressed them. So this is to save network bandwidth. It compresses all the objects before it sends them. It wrote the objects to the remote server, and then it created a new branch on the remote. So before flash stick had no branches, in Git you have to have a branch, and by default it'll create you a master branch. Because we created a bare repository on flash stick, there was no branches, so we had to create one. And that's it. Seriously, that's all we have to worry about now. If we change this file, vim readme.txt, and create, go down here and edit this and say this version is about to be pushed to the flash stick. Save and quit, that's what WQ means. Now if we type git status, readme has been modified, well, let's not worry about the staging area. We just want to commit everything. So git commit -a. Okay, modified version ready for backup. Save and quit. We've committed that. Remember that commits are local. So if we want to get this onto our flash stick now, we have to push it again. So how do we do that? Git push flash stick. And it's done. We didn't have to put a branch name here because we did it the first time we created the branch. So again, this is all status updates as it's executing, and we push the commit, and that's it. Now we have a backup. As a developer, we can work on our local copy all day, and then at the end of the day we push our changes to flash stick, and flash stick has a full copy of the Git repository, which is pretty cool. And we don't have to copy files manually or anything like that. We just do a git push, and Git handles everything for us. So